Okay guys, in this video we're going to talk about moles and molar mass. So the first thing that we want to ask ourselves is like, what is a mole? Like, what does that mean? Alright, well, in chemistry, not the animal, in chemistry. So mole is basically a counting unit. Okay, so when we're talking about counting unit is basically any word that needs a very specific number. So like, for example, we have pair. When we talk about a pair or something, we're talking about two. Let's say if we're talking about a dozen, we know if we say, hey, a dozen donuts, we're talking about 12. If we said trio, right, we know that we're talking about 3. If we're talking about triple, 3, quadruple, 4. So these are basically counting units. Okay, so it's just a word that means a very specific number. All right, now when we're talking about mole is the same thing. It's a term that means a very, very specific number, and that number that we're talking about in this case will be, so a mole, or 1 mole, represents 6.02 times 10 to the 23 of anything, any substance that we're talking about. Okay, so just like when we're talking about a pair of shoes. Alright, so when we talk about a pair of shoes, we're talking about basically 2 shoes, right? Or if you're talking about a 1 dozen of donuts, okay, we're talking about basically 12 donuts. So in the same way here, if I said I have 1 mole of cats, well, that simply means I have 6.02 times 10 to the 23 cats. Okay, so the bottom point, the most important point here is that 1 mole of a substance represents 6.02 times 10 to the 23 of whatever we're talking about. So how does that relate to anything that we're talking about when it comes to chemistry? Well, when we think about moles allows us to look at atoms not as individual, but as a packet of atoms. The problem is atoms are just way, way too small for us to count. And even to this day, we know we have yet to see exactly how the atom looks like. Or you have any instrument that's powerful enough that help us to actually see what the atom looks like, what it composes. So it's really difficult for us to count it out. But if we count it out as packets or as a mole of a substance, okay? So like, for example, like you have this simple equation here where you have 2H2 plus O2 yields 2H2O. Now recently we will say this. We will say that for every 2 atoms of H2 reacts with 1 atom of O2 to make 2 H2O, 2 molecules of H2O. Well, what we could say now, instead of saying atoms, because really we can't count all atoms, we could say, well, if we have 2 moles of H2 reacts with 1 mole of O2 to form 2 moles of H2O. All right. So we could look at it in that sense. All right. Now that we know this relationship between mole and the actual number, so what we could say that if we have 1 mole of carbon atoms, all this simply means that we have altogether 6.02 times 10 to the 23rd atoms of carbon. Okay. If we have 1 mole of H2O molecules, okay, then that simply means that we have 6.02 times 10 to the 23rd molecules of H2O. Alright, just to kind of define a couple of terms here. Molecule, anytime we use that term, we're talking about a covalent compound. So 2 nonmetals joined together, they're considered, or any nonmetals joined together in a compound, we typically call them a molecule. Or if we have 1 mole of NaCl, and elements that are, or compounds that form from a metal and a nonmetal, we call them formula units. Okay, So in this case, if we have 1 mole of NaCl formula units, basically we have 6.02 times 10 to the 23rd formula units of NaCl. Alright, so the point is, as I get, just stressing it, if you have 1 mole of any substance, you have 6.02 times 10 to the 23 of it. So let's consider this, alright? So if you have, as I said earlier, 1 mole of H2O, okay? And that equates to 6.02 times 10 to the 23 molecules. Molecules and moles are not the same thing. Molecules of H2O. Alright, so for every 1 mole of H2O, alright, you have 2 moles of H. How do we know that? Let's look at the chemical formula, right? So for every 1 of H2O, you have 2 H's. Okay, kind of makes sense if you think about it in the sense that, you know, for every car that you have 4 tires. Well, if you have a sedan, you have 4 tires. Okay, that's just for every one car. So just like for a water molecule, alright, so for every 1 mole of H2O, we have 2 moles of H's. And if that's true, we also have 1 mole of oxygen. So what does that mean? So as I said earlier, we know that for every 1 mole of H2O, you have 2 moles of H, and we know that 1 mole of H is 6.02 times 10 to the 23rd molecules of H2O. Okay, so then that simply means that in this case, if we're talking about moles, then we have 2 times 6.02 times 10 to the 23rd atoms of H in every 1 mole of H2O. Alright, and so if you were to multiply this, you'll get 1.204 times 10 to the 24. So that's how many atoms of H do we have in 1 mole of H2O. Okay, and the same idea with the oxygen. So we know we have 1 mole. For every 1 mole of H2O, we got 1 mole of oxygen, because you know it's a 1 to 1 here. So you have 6.02 times 10 to the 23rd molecules of H2O for every mole, or 6.02 times 10 to the 23rd molecules of H2O. You also have 6.02 times 10 to the 23rd atoms of O. Okay, so that way you could see and understand the relationship between molecules, compounds, and the substances or the elements that makes up the compounds themselves. So the question now is, what's the point? Like, what's the application of moles? Like, how do we use it? Well, moles gives us the ability to basically to count by mass, all right, or count by weight. So like, for example, let's just say you were given a task to count each and every grain of rice that you have from a large bowl of rice, all right? And when you kind of think, that's a daunting task. That just sounds like if you were placed into punishment and they give you a bowl of rice and say, hey, count each and every single one of them and tell me how many rice grains you have in a big bowl, all right? But essentially, we do this all the time in chemistry, all right? But we don't go in and count the atoms because, as I said, it's way too small. But we take the mass of them, and knowing a conversion or two, we could easily figure out how many atoms or how many molecules or how many specific formula units we have in any substance. Okay, so like, for example, let's just say, well, let's go back with the rice example, right? So with the rice example, let's say you were giving a bowl of rice, and within the rice, the mass of the whole bowl of rice was about 1,500 grams. Okay, so you figured out that the rice in itself, a grain of rice, and you managed to take the mass of it, the grain of rice is 0.15 grams. All right, so we have, all right, so your total is 1,500 grams of rice. So that's the mass of your bowl of rice. But each rice grain, so for every rice grain, has the mass of 0.15 grams. Well, if you know this, then you could easily figure out, all right, how many rice grains you have in your whole bowl of rice. So how you'll do this, and just kind of go through the simple calculations with you. We'll use the method of dimensional analysis to help us figure this out. But we know that total bowl of rice has the mass of 1,500 grams, okay? Well, we also know that per rice grain is 0.15 grams, all right? So per rice grain. So now when we do this math, right, so everything crosses out here. So 1,500 times 0.15, then you have it that you have about 226 grains of rice, roughly. Okay, and you know, just assuming that they're about the same size and the same weight, but give and take, you're going to have roughly about 226 grains of rice. All right, so same idea with chemistry, same idea. All right, so we'll know that, okay, for every 1 mole of carbon, it weighs, the mass of this is 12.011 grams of carbon atoms. For every 1 mole of oxygen, okay, has the mass of 15.999 grams of oxygen. Now, where are we coming up with these numbers from? It's from the periodic table. These are your average atomic masses. So it turns out your average atomic mass is also what we call the molar mass of the element. All right, and so let's just quickly talk about what is a molar mass, and then we'll go back to this periodic table to investigate this even more. So when we talk about molar mass, all right, molar mass is simply the mass of any substance when you have exactly 1 mole of it. All right, so if you have 1 mole of a substance, it's its mass. All right, so kind of going back up here, if we have 1 mole of carbon, the mass of that 1 mole of carbon is 12.011 grams. If you had 1 mole of oxygen atoms, its mass is exactly 15.99 grams of oxygen. All right, and so let's kind of just zoom in and look at this periodic table. So if you remember, your average atomic masses are these decimal numbers here. Okay, now these numbers also represents the molar mass of each of these elements. So for example, the molar mass of aluminum is 26.902. The molar mass of nitrogen, 14.007. If we're talking about sulfur, if it had 1 mole of sulfur, what would be its mass? 32.066. If I had 1 mole of iron, what would be its mass? The mass is 55.845. Okay, and so the way we kind of look at this, all right, and if you were to write up as units, then we say that, okay, well, if we have, well, wrong utensil. If you have, for example, carbon, so we know that for every 1 mole of carbon has the mass of 12.001 grams of carbon, then we will simply say that the molar mass of carbon is 12.011 grams per 1 mole. All right, and that's the units for molar mass of, that's the units for molar mass, and regardless of whatever substance that we're talking about. Now, let's say that we were talking about compounds. How does that look? So with compounds, basically, when we're trying to figure out the molar mass of a compound, it's just simply the sum of all the molar masses of each of the individual elements that makes it up. All right, so it's really important that you have your periodic table in this case. All right, so let's kind of look at this in total. All right, so let's just say we want to know the molar mass of NaCl. All right, that's what we're trying to figure out. So you look at the periodic table and you'll try to find, okay, so here we find Na, and we note that Na's molar mass is 22.990, okay? And you look for chlorine and you note that chlorine's molar mass is 35.453. So what you're going to do, you're basically going to add them up. All right, and so here we see that Na, once again, its molar mass is 22.990 grams per mole. All right, chlorine's molar mass is 35.453 grams per mole. All right, and so to figure out the molar mass of NaCl, we're just simply going to add them up together. All right, and so what you'll do is 22.990 plus 35.453, and then what you'll find here is that the molar mass is roughly 58.44 grams per mole, and that's the molar mass of NaCl. All right, let's look at another example. Let's say we're trying to figure out the molar mass of lithium oxide. All right, once again, the molar mass of a compound is simply the sum of the elements that make it up, okay? And so you look at the periodic table here. Ooh, excuse me. All right, so you'll find that lithium has a molar mass of 6.941. You also find that oxygen has a molar mass of 15.999. All right, and you'll just simply add them up. So here we have lithium, all right, Li, once again, whoa, right there it is. All right, so we have lithium, and we said that its molar mass is 6.941 grams per mole, but if you notice, we got two of them, so we gotta take account that there's two lithiums. And then oxygen is 15.999, all right? And so we're just going to simply add them up together. So we have 6, well, that's not a 6. We have 6.941, okay, grams per mole times 2, okay, plus 15.999. And well, it turns out that the molar mass of lithium oxide is roughly 29.9 grams per mole. Okay, and we could even go so far as let's look at another example. We have aluminum oxide. Okay, so take note that you have 2 aluminums and 3 oxygens. So you look at your periodic table. So let's zoom into our periodic table here. And then we see that for aluminum, our molar mass is 29.982. Oxygen is 15.999. And so now we're going to go and 26.982. All right, so just trying to remember that. So let's go ahead and figure out the molar mass of this compound. All right, so we have aluminum, which is, keep on doing this, aluminum, we have 26.982, and there's 2 of them, okay, plus oxygen, which is 15.999, and there's 3 of them, okay, so here's the molar mass of aluminum, here's the molar mass of all the oxygens, and we're just simply add them together, all right, and that will give us the molar mass of this compound. All right, we could do one more. Let's get kind of crazy here. All right, let's look at ammonium nitrate. Phosphate. Oh, phosphite rather. So NH4 3PO3. Once again, it's just the sum of all the molar masses of each individual element, all right? And so the way you will do this, you just kind of, write it up. So you have nitrogen. We know that nitrogen has the molar mass of 14.007, okay? And there's 3 of them, all right, because you have to distribute the 3 inside. Hydrogen, it has a molar mass of 1.008. All right, and if you distribute this 3 inside, so it's 4 times 3, that gives you 12. All right, we have phosphorus, which has a molar mass of roughly 30.9. All right, and so there's only one of them. And oxygen has a molar mass of 15.999, and you just multiply that number by 3. So when you add them up together, you'll get the molar mass of ammonium phosphite.